Good morning, everyone. My name is JB Lee. This paper is about real-time monitoring of inflammation in metabolic syndrome with the electrochemical detection of tyramine in urine. So the first author of this paper is Tanzila Noushin. She was supposed to be here, but because of the visa issue, she was not able to travel. So I'm presenting for her. So medical testing, as you know, the conventional medical test is blood testing and nasal swab, and that's often the invasive. And so we are looking for alternative method of this testing, and one of the convenient way is to testing urine, which is non-invasive. Limitation of the current technologies, it requires the relatively large volume of samples and invasive sample collection and relatively slow process. And it is challenging to reach rural areas and underprivileged areas. And often it is difficult to find the multiplexed sensing options. So electrochemical sensor is one of the good way to provide alternative solutions. Electrochemical sensing, you can give the rapid point of care detection and continuous real-time monitoring and potential multiplex detection and potential making it wearable and implantable sensors, and pretty cost effective and simple fabrication process. Often it is possible to make the roll-to-roll production. So that's the some motivation of this work. So here we have this gold standard technology today that high performance liquid chromatography and mass spectrometry and the capillary electrophoresis, and those technologies are conventional technologies. And once again, electrochemical sensing, rapid detection and cost-effective on spot, and ease of operation, and user-friendly, and good sensitivity and suitability. So what we are trying to do here in this work is detecting tyramine in urine. So tyramine is a potential early biomarker for the detection and monitoring of metabolic syndrome, METS, which regulates the development of both type 2 diabetes, mellitus, and atherosclerotic cardiovascular disease. So it actually affects 1/3 of the US population. So it's a pretty significant problem. And so comparing patients with METs to controls, it was observed that the tyramine concentration in collected urine sample exhibited about the 5-fold reduction in METs patients. So there was a significant difference between healthy individual and this METs patient. So far, the limited research has been conducted, and paucity of the data exists regarding tyramine levels, detection in urine, and real-time monitoring in early stage METs is not really well studied so far. So we thought that the development of cost-effective and highly sensitive sensor holds great promise for the treatment of METs and various diseases associated with tyramine concentration in urine. So fabrication of the sensor is pretty straightforward and simple. So nothing super exciting. There is no nanotechnology or something like that at all. Pretty simple, straightforward process. So polyimide and transport tape, and we use the craft cutter and just to make the 3 electrode system. So so the center electrode is basically the reference electrode, and there is a working electrode and counter electrode. So this simple the craft cutter based roll-to-roll production is done, and the size of the preliminary device is relatively large, like the millimeter scale right here. And so this center, the electrode is the reference electrode. So basically the transport tape was attached to the polyimide and patterning the sensor design in this craft cutter. And screen printing steps is next. So electrode pattern was on the transport tape, and transport tape with the reference electrode pattern was peeled up, and silver chloride was screen printed and cured. So basically in this stage that you just peeled off this transport tape, and now you are exposing this. So this is the screen printed with silver chloride, and then we peeled off the working electrode and counter electrode, and the working electrode and counter electrode were screen printed with graphene and cured. So these two working and counter electrode is just the graphene coated, and it is cured. So very straightforward process. And to make the function to functionalize the working electrode, so we put the toluidine blue TBE solution. It was prepared in PBS, and then the polymerization of the working electrode was achieved by employing the cyclic voltammetry technique for multiple cycles, just about the 20 or so cycles, and it is well polymerized and it works quite well. So working electrode was modified with this the toluidine blue, so that is the key component right here. And the Tyramine sample in level in urine of healthy individuals falls within the range of the 25 to 60 nanomole. So we prepared the 11 different solutions. So 11 different solutions with different Tyramine concentrations, and from all the way down to 1 nanomole to very high, the concentration of 200 micromole. So very wide very wide range of the Tyramine sample was prepared. And the detection was done with cyclic voltammetry. So in the we are using this smartphone-enabled electrochemical sensing system. So this the system is connected with Bluetooth to the smartphone. So you can have all these results in your smartphone, and this data can be extracted out, and you can just plot it. So once you look at this, the graph right here, this shows the current and the potential, so typical cyclic voltammetry. And the black color right here, that is graphene electrode. So graphene itself, so once it is functionalized, this is what you see in cyclic voltammetry. And once you put the Tyramine there, it is right here in red color. And if the working electrode is activated with toluidine blue, and then Tyramine is added, then you can see this the gigantic shift of this peak in cyclic voltammetry. So the amount of the current that you can see from control sensor and toluidine blue, the modified sensor, that you can see this kind of the difference. So cyclic voltammetry was conducted to the toluidine blue modified graphene electrode with various concentration of Tyramine, and we continued on this measurement. So as I said, it is pretty wide sensing range. So we prepared the solution all the way down to 1 nanomole to 200 micromole, and we could see this kind of two distinctive range right here. So we just divided this into two. So from 1 nanomole to 500 nanomole, so lower concentration, and 1 micromole to 200 micromole, higher concentration region. And we got this plot, and get the sensitivity. So this is raw data for all these different concentration of cyclic potentiometry, and we got this the plotted data for sensitivity. So in terms of the sensitivity, we got 431 microampere per micromole per square centimeter, and it gives the wide dynamic range, and limit of detection is pretty low, 39 nanomole. We also tested about the reproducibility and stability. So the first graph down here, it shows the 3 different sensors for different concentrations, that you can see a slight variation that is just about the 6% variation in response. And we also tested the stability for the same sensor for 5 different 5 days, and 200 micromole and 1 micromole and 1 nanomole, and we tested this for 5 consecutive days, and the variation is just about 5% within the range of the sensing. And we also tested the selectivity. So because it is a urine sample, the common interferent in the urine is basically nitrite and glucose. So typical healthy individuals, concentration of glucose is just about 500 nanomole, and nitrite is about the 80 nanomole in urine. So we have those things as interference, and here it shows that interference that we could see almost nothing, and 1 micromole tyramine and interference, and we can see this, and 10 micromole and tyramine, 10 micromole tyramine, and the interference that we can see this. So this shows that this polytoluidine blue based the detection shows the good selectivity over common interference in urine. So all right, so basically we have pretty wide sensing range, and limit of detection is good, and this is once again pretty straightforward, pretty straightforward electrochemical sensor. One quick presentation here is that if you are involved in olfaction or electrochemical sensing, we have conference coming in Dallas, Texas, so Grapevine, Texas, and you can find the information here, and hopefully you can join this conference. So that's all I have. So,
thank you so much.